This video is over Objective 17.4, Transformations of Functions. We're going to start in the vocab section of your lesson. First thing we want to write the equation of the parent function for each of these types of graphs. In Lesson 3, we learned three types of graphs as well: linear, quadratic, and exponential. So we're adding three more to our mix that you will have to be able to identify by graph, by name, and by equation. And in Lesson 3, we actually learned how to identify it based on a table of values as well. So this first type of function is an absolute value function. In an absolute value function, the parent function equation is the absolute value of x. This particular piecewise function, basically a piecewise function is a function or a graph that's made up of pieces of several different graphs over certain domains. And so if we look at this piecewise, oh, sorry, that is a really bad curly brace. Let me try that again. So typically when we're writing piecewise functions, we have a curly brace, and then we have each function and over which domain it exists. And so we're going to start with this blue function. And this blue function is, if you continued it in the direction that it is going, it has a slope of 1. So we're going to do 1x, and it would have a y-intercept of 2. So x plus 2 when x is less than or equal to negative 1. Now you just have to be able to identify these by their graphs and by the way that their equations will look, but I want you just to take a look at that. This function is only from here to the left, and so notice the x value there, negative 1. So it exists when x is less than or equal to negative 1. Alright, so then let's take a look at this red function. So the red function is a horizontal line through 1. So this is f of x equals 1 when x is between negative 1 and 1. So notice that's between that range. And you learned how to write those inequalities back at the beginning of Algebra A last year. Alright, this last function that's represented on this graph is the green one. And it has a slope of 3, and if you continued it, it would cross the y-axis at negative 2, and that is just for when x is greater than or equal to 1, because notice it goes this way from x equals 1. And so that's what a piecewise function equation looks like. It is pieces of different graphs, and so we have different equations with the domains listed. Now this last type of function doesn't have quite as funky as a equation as the last one, but this step function, it has this special looking, oh, that didn't write the way I wanted it to. It's a special looking brace like this with an X inside. And so like I said, right now you really just need to be able to identify these, and that is what our focus will be in this unit. Alright, in this second part of the notes, we are identifying different types of functions by their graph and by their equation. So you can use your notes if you want to, but I want you to pause the video and I want you to write what kind of function each one of these is on the line below it, and then unpause and you can check your answer. Okay, so hopefully you pause the video, and now I want you to check your answers. So this first one's absolute value. We know that because of its V shape. Second one is quadratic. We know that because of its U shape. This third one, there's only one type of function that's going to look like that. It literally looks like a staircase, and we call this a step function. On this next one, anytime x is the exponent, it's an exponential. This next one looks like y equals mx plus b, so it is linear. And this last one, notice just that we have two different pieces. That's how you know it's a piecewise. So kind of see how you did there. Ask yourselves why you missed any that you missed. Alright, so this next section, I'm actually going to pause and I'm going to write in these little definitions, and then I want you to copy them down. Okay, go ahead and write down these little explanations that I gave you for each type of transformations. In order to explain transformations in an equation sense, I went ahead and wrote the general equation for a quadratic that's been transformed up at the top, and then I gave you what each value of the equation does. So, for example, and I'm just going to give you a quick example here, even though there's one on the next page. If you had, for instance, y equals negative 3x minus 2 squared plus 1. So this value, this negative 3, is the a value. And that tells us that it is stretched, which means it's going to be skinnier than the parent function, and that it's going to be flipped upside down since it's negative. This negative 2 that is inside the parentheses with x, and that's the key there, it's inside the parentheses, that tells us that it's going to be 2 left. And so that number with the x is kind of does the opposite of what you would think it would do. If it's negative, it makes it go left, and if it's positive, it makes it go right. And then this number out here tells us it's up and down movement, and it does exactly what you would think. If it's positive, it's going to go up. So this would be stretched, flipped, 2 left, 1 up from the original parent function. So your original parent function starts at 0, 0. That's where your vertex is. And it kind of looks like this. Maybe not quite that narrow. Probably more like what I have on this left side here. So let me fix that right side. Okay, so here's our parent function. So in this case, this would move our vertex 2 to the right and 1 up. So now our vertex is here. And it's actually going to flip it upside down and make it narrower. So kind of like that. It's a very rough sketch, but be comparable to what you are doing with the actual transformation if you really graphed it in its points. All right, so let's go ahead and look at this section down here. So all you're supposed to do here is compare the graph to the parent function. So the thing about this is you kind of have to know a little bit about the parent functions. So with your absolute value parent functions, you can catch that on the page that we started with here on the beginning of lesson 4. I gave you the 3 parent functions for this lesson, and you can see a picture of the absolute value parent function, which has it basically looks like this. It has a vertex here, and then it has a slope of 1, and then it goes that way, so it's mirrored over there. So here's our parent function. So if you take a look at this, we can see that our new function is 1 right and 4 down, and it seems to be stretched, meaning it's a little skinnier than that original parent function. So let's look at the second one. Same thing. We have 2 left. We have 3 up. It's flipped upside down, so I'm just going to write flipped. And notice that the slope here is going down 1 over 1, down 1 over 1. That means that the slope is the same as the parent function. So in order to really make those comparisons, you need to know that the absolute value and the quadratic parent functions both start at 0, 0 for the vertex. And you also need to know that the linear parent function goes through 0, 0. You should be safe if you know those 3 things. Lastly, in this section, you're supposed to be able to look at the equation and list the transformations, which we just did an example for. So on this one, we're going to look at this negative 2 and this 3. Those are the extra numbers. Here, we're going to look at this 2 and this negative 4, this negative, and this 1 on this last one. So this 2, it's in the parentheses with x, and it's negative. That tells us it's going to go 2 left. You will need to memorize what those different parts of the equation do as far as transformations go. This 3 right here is being added to the outside. That tells us that our entire graph is being moved 3 up. On this next one, this 2, this is our a value right in front of the x squared. It is greater than 1. That means it is being stretched. And this negative 4 is not in parentheses, which means that it is moving it down 4. Now, if it had been in parentheses with the x like it was on this first one, that's when it's left and right. Okay, so on this last one, this negative in front, that tells us it's flipped upside down. And then this 1 is in the parentheses with x. That tells us it's going to be 1 to the left. Remember, that's kind of opposite of what you would think it would be.